So now I'm going to go over confidence intervals for averages. You've seen videos on confidence intervals for proportions. Now we're just going to do it for averages so we can do it for quantitative data. Your book covers this when sigma is both known and unknown. When sigma is known, that is, we know the population standard deviation, then we can just use a z-score, and so that's pretty straightforward. It gets more complicated when sigma is unknown because, again, we have to use the t-distribution. When sigma is unknown, which is much more common in application, then we have to use the t-distribution and account for the degrees of freedom again. So the way we construct a confidence interval when the standard deviation is unknown, we use our sample to construct that confidence interval. So the sample average is our starting point, and then we reach up and down, again, some margin of error. Our standard error is how much we think the samples would vary, and that's going to depend upon our sample standard deviation and our sample size. The critical t then is based on the degrees of freedom. This is again n-1, and then it's based on the t distribution. I'm going to show you how to find these critical t's in a second. Before we get to the critical t, let's remember that for our confidence interval, we determine beforehand how confident we want to be. The most commonly used confidence levels are 90, 95%, or 99% confident. To find the critical t, you're going to need a t-table. Now, your book provides you one. It's back in the Appendix E, and you could utilize that, or you can even Google one, and Googling gives you a whole host of different distributions. So here I have the t-table. This website even gives me z-tables and f-tables as well. Those are different types of tests. The two things we need to know are our degrees of freedom and then the confidence level. So here, this t at 0.90, that would be a confidence level of 90%, 95%, and then 99% is over here. But again, you can specify any of these confidence levels. These are the critical t's based on the degrees of freedom that we observe. So as you can see, the more degrees of freedom you have, the closer you are, the smaller the critical t for any confidence level. So all of your critical t's get smaller. You can see here at infinity, these numbers might look very familiar. They are the normal distribution. So as I said before, the t-distribution, as you increase your sample size, goes towards that normal distribution, and that's why these values are exactly those of the z-distribution, or the normal model. So let's try a problem really quickly so you can see how the t-table is utilized to get that critical t and how we construct the confidence interval. Here we have some students who are investigating the packaging of potato chips, and they go out and they buy 6 bags of potato chips from Kroger. They're all marked with a weight of 28.1. Now this is just what it says on the bag. Sometimes the manufacturer fills them more, sometimes less, so we just want to make sure that the average amount of potato chips in each bag is at least this amount, 28.1. So of the 6 bags that they collected, these were the varying weights, and you can see that they're all greater than what it says on the bag. We want to create a 95% confidence interval for where we think the true weight is. So here again, I plugged in our observations into an Excel file and calculated the average and the standard deviation for the sample. So I'm going to use these two summary statistics to create my confidence interval. So the way the confidence interval is generated is starting at our sample average, and then we reach up and down some margin of error. The margin of error is our critical t times our standard error of the sample. sample averages. So this includes both our sample standard deviation, and then we divide by the square root of our sample size. We had 6 bags of chips, and so now we're square rooting by 6. Again, we don't square root this whole term because our standard deviation has already been square rooted. We only need to square root the number of observations. So that's how I get this number. Now let me show you how I got the critical t. Remember that the confidence interval that we're interested in is a 95% confidence interval. Now it may be tempting to go to the column that says 95, but that would be incorrect because this is the cumulative distribution function. So it's saying that the upper tail is 5%. If we use this value, the confidence level would actually only be 90%. If we used this value, our confidence level would only be 80%. So the correct value that we want to use is 0.975 because that's going to give us an upper tail and a lower tail of cumulative 5%. This represents only the upper tail of 2.5%, and so because of symmetry, we will get a total of 5%. We want to go down this column then to 5 degrees of freedom. Remember that our number of observations was 6, so we have 5 degrees of freedom. So 2.571 is the correct answer. So that's how I got this critical t value of 2.571. Now on ReggieNet, I will put a Word document or a PDF of the t-tables. One that's a little bit more easier to use that shows you the actual confidence level, and it's a little bit more straightforward. The one in your book is much like the one I just showed you, where the TCDF you have to take into consideration. Once we have the lower bound and the upper bound, we construct our confidence interval, and we can be 95% confident that the true average lies in this range based on how we've constructed the interval. So we have evidence that the true average weight of bags is actually greater than 28.1. You can see this because 28.1 is not in this interval. It's in fact less than it. So we can state with 95% confidence that the true average weight is greater than 28.1 because 28.1 is less than where we think that true average weight lies. So that's how you construct a confidence interval for one sample t-test for averages. Again, in this example, our sigma, our population standard deviation, is unknown. So we're using our sample to construct the entire interval. I will put on ReggieNet the table for these critical t's so you can work with learning how to use them. In the next video, I'll go over a few more problems so you can see the t-tables in action.